Hello everyone. In this session, I am going to explain about the properties of hydraulic fluids. That is also called as desirable properties of hydraulic fluids. The hydraulic fluids, what we are using in the hydraulic systems as a working fluids, those should be possess some of the properties. And what are those properties we should consider for the using in the hydraulic systems? Those properties are here. First one is the viscosity. It is a measure of fluid's internal resistance offered to the flow. The viscosity is the resistance offered by the one layer of the fluid to the another adjacent layer of the fluid. If the resistance is more, then the pressure is to be applied for the flow of the fluid is more. Therefore, the viscosity plays an important role for the power which is to be required for the flow of the fluid during its operation. That's why the fluid whatever we are going to use, it should be having the less viscosity. The next one is viscosity index. The viscosity index means here the viscosity of the oil varies with respect to temperature, and viscosity index whatever is there, it should be lower. That means the variation of the viscosity with respect to temperature should be less. That should not vary, so that the system can be operated with a different temperatures. At a higher temperature as well as at lower temperature can use the hydraulic system. And this value shows how the temperature affects the viscosity of oil. The viscosity of the oil decreases with increase in temperature and vice versa. The rate of change of viscosity with temperature is indicated an arbitrary scale called viscosity index. That variation is measured. Okay, that should be lower one. Third one, oxidation stability. The whatever fluid we are going to use, that should not be get react with oxygen, and it is get react with the oxygen from the either oil oxygen present in the oil itself, or from the some of the dissolved air in the oil. If it is get oxidized, then that becomes a that somewhat its stability it will lose, and that is the reason it should have the oxidation stability. The most important property of hydraulic is its oxidation stability. Oxidation is caused by chemical reaction between oxygen of the dissolved air and the oil. The oxidation of the oil creates impurities like sludge, insoluble gum, and soluble acidic products. These will be found due to the oxidation of the oil. The soluble acidic products cause the corrosion, and insoluble products makes the operation sluggish. That's why the oil which is to be used, that should have the oxygen stability. Further moving, next one, deemulsibility. Deemulsibility means the ability of the hydraulic fluid to separate rapidly from the moisture and successfully resist the emulsification is known as the deemulsibility. The emulsion formation. That emulsion formation means whenever that oil is there, that oil during the working in the system, that will uh, whatever the it should not separate from the that moisture what is present, and it should not form some of the form called a emulsion, okay, which is having the higher viscosity, and it is not a good working fluid. To form that emulsion, okay, it should not be uh, tend towards that one. That's why it should be demulsibility property it should have. Okay, it should not become a emulsion of that fluid during its operation. Next one is lubricity. Here, the one of the major benefit of the hydraulic system is that now all the moving parts which are present in the hydraulic systems, or to be lubricated in order to reduce their friction. And anyhow, we are using that hydraulic fluid in the system that will serve the purpose of the lubrication. That's why it should have the lubricity. The ability of the hydraulic oil fluid to lubricate the moving parts efficiently is called lubricity. The hydraulic oil what we are using that should have the lubricating capacity, that is called as a lubricity. Should have the lubricity. Next one is a corrosion prevention. Here, the whatever this hydraulic fluid we are using, that should not react with all the metallic parts present in the system, and it also should be avoid from the exposure to the oxygen to form a corrosion. And that's why the oil layer whatever formed on the surface of the metals will prevent the corrosion formation. That property it should have. The moisture entering into the hydraulic system with air causes the parts made of ferrous materials to rust. This rust, if passed through precision made pumps, valves, may scratch the nicely polished surfaces. So, inhibitors added to the oil to keep the moisture away from the surface. And that oil layer formed whatever on the surface is there that will keep away the moisture from the surface so that the ferrous rust formation or a corrosion formation will be eliminated. Next is a pour point. The pour point means the point at which the temperature at which the hydraulic fluid will be get solidified at a lower temperature usually. That is we'll call as a pour point, or it's we can call as a freezing point also. It should not freeze to a form a that solid, so that it can work at a high range of the high range of temperature. At a higher temperature also it can work at a lower temperature. And whatever the hydraulic fluids we are using, some of the cold countries where the temperature is below 0 degrees Celsius, at that point also this working fluid can be effectively used in the hydraulic system. That's why it should have the lower pour point. The temperature at which oil clot is referred to as a pour point. That is the lowest temperature at which oil is able to flow easily. Okay, above that one it will flow easily. Moving to next one, flash point and the fire point. The flash point means already we know the definition. Momentarily the fluid which catches the fire, okay, it catches the flame, and that flashes into a that flame. That is called as a flash point. And the fire point is the point, the temperature at which it will be catches the fire. Okay, it is ready to burn. And those two temperatures should be higher one, so that we can work in the higher temperature environment also the system can work. Flash point is the temperature at which liquid gives off vapor in sufficiently quantity to ignite momentarily or a flash when the flame is applied. The minimum temperature at which the hydraulic fluid will catch fire and continue burning is called fire point. And these should be higher. These two temperatures should be higher. The neutralization number. The neutralization number is a measure of acidity or alkalinity of a hydraulic fluid. And this refers to a pH value of the fluid. High acidity causes the oxidation rate in an oil to increase rapidly. That while neutralization number means it should not be acidic, it should not be alkaline. It should be closer to the neutral. Okay, that is called as a neutralization number. It should better neutralization number it should have. 10th one is a density. Density, it is a quantity of matter containing in a unit volume of the substance. That is mass per unit volume of the substance, that is called a density. It should have the lower density so that its weight will be less. and its volume will be more. Okay, by that one we can get the that is total weight of the system will be lower one, so that with the lower weight only we can get the higher fluid work. The last point is that compressibility. Here all the liquid fluids what we are going to use, those are incompressible. As well, already we know while taking the properties of the fluids. And the compressibility should not, it should not have, it should not compress during the working fluid. The compressibility of the fluid should be very less, so that it will not be get compressed during the working. Here higher pressure we are going to apply during the working of the this hydraulic systems. During with that high pressure it should not get compressed, ensure that the fluid should have the lower compressibility, and then we can use that as the hydraulic fluid in the hydraulic systems. All fluids are compressible to some extent. Some extent, even though liquid fluids are compressible, but all the gaseous fluids are compressible, liquid fluids are incompressible. The compressibility of liquid causes liquid to act much like a stiff spring. Okay, if it is not compressible, it will be a stiff spring. The coefficient of compressibility is a fractional change in a unit volume of a liquid per unit change of a pressure. Okay, but even the fraction change is there, okay, that should be there. It should not change fractionally. These are the different properties of the fluids. Those should be as per the requirement in order to use the particular fluid as the hydraulic fluid. And all the fluids naturally which are available or manufactured fluids, those are not having all these properties, so that those requires some of the additives to be added. And what are the requirement are there for using the hydraulic fluids, and what are the additives we are going to use for the hydraulic fluid in order to get the desired properties. Those I am going to explain in further sessions. Thanks for watching. If you like, share, subscribe, and comment.